Okay, here's a couple circuits that we want to look at, but we're going to codify some of the things that we've been doing. And one guy who did that was Kirchhoff. Sometimes it's called Kirchhoff. His rules where we begin to look at circuits and then using the conservation laws that we know of, came up with a set of rules that work. So first we're going to have the junction rule. And really this one is conservation of charge. So what that means is when we have current coming into a junction, it's water in a pipe. It either has to go this way, so we'll call this current 2, or it can go this way. But that's kind of small, so let's zoom in on this. There it is. All right. So now when we have, that means I get to use the other side. So when current is coming into the junction, this is current 1. When it hits this junction, it's either going to go this way, or this way. So if on my, this is I2 and this is I3. So what that means is the charge can't leak out anywhere else. It has to go this way or it has to go that way. So I1 equals I2 plus I3. Now, if you look at this, we have another junction right there. Oh, look, it's just this. All right. So this junction here is the same thing. I3 is coming down, I2 is coming in. That has to equal I1 coming out. So junction rule, conservation of charge. I1, basically IN has to equal I out, I2 plus I3. The other rule is conservation of energy. This is called the loop rule. And we kind of know this one already as well. This is conservation of energy. So when I start on one side of the circuit and I do a complete loop. So I start here. Well, here, this is too small. Let's go somewhere else. Let's zoom in on this. Here we go. So when I start here and work my way around and come back around, when I come back to that point, all of the voltages are the same. I'm sorry, I said that wrong. All of the voltage rises in a closed loop must equal, I spelled equal wrong, equal to the voltage drops. So, step number 1, choose your loop. All right, so I'm going to start right here. Here's loop 1. All right, here's number 1. Now, this didn't get put in, so I have to put that one in. So let's go to loop 2. I'm going to choose this as loop 2. Now your key to them, they must be mutually acceptable. Meaning here and here, they both have to be pointing the same direction. Here and here, they have to be pointing the same direction. Now I'm going to label number 2. Label drops and rises. So we started here. My current is flowing this way, so this needs to be on the high potential side. This needs to be the low potential side. However, batteries are what they are. This is the negative side. This is the positive side. So there's loop 1. And now let's label let's label loop 2. Loop 2 didn't get a number. Let's label loop 2. So current's flowing from this side down to this side, and then there's my battery again. So taking a look at this, there's my label, my drops. Now we are going to apply our junction rules. Now we apply our loop rule. I'm sorry, loop rule. So loop 1, starting here, I'm working my way around. This is, I'll call this current 1. This is, I already have this called current 2 moving through there, and then this is current 3. So loop 1 for current, I have current 1 going across here. This is resistor 3, and here's resistor 2. Coming through here, I have a voltage drop. So here are my voltage rises and drops. My voltage drop is V equals, remember V equals IR. So I have a going from high potential to low potential. That's a drop. So I'm going from high potential to low potential. That's a drop of I3 times R3. And then I come back to my, call this V battery. My voltage of the battery, low potential to high potential, is a rise. Okay, so V of the battery has to equal I3 R3. And then let's take a look at loop 2. Loop 2 rises and drops. I start at the same place. Loop 2, oh, this is the green and I picked the wrong one. That's great. So now I'm coming across here. I have I2, here's my voltage drop, high potential to low potential. I have I2 going across R2. That's I2, R2. And now I come back around, follow the current around, and then I have a low potential to high potential. That's the voltage of the battery. So this tells me that the voltage of the battery is I2, R2. So now, oh, look at that. It's something I already know. When they are in parallel, they should be at the same voltage. Very nice. So that's how you do the loop rule. In our next video, we'll do some examples.